Welcome to Akshara Academy YouTube channel. In this session, I am going to discuss Ntse SAT Physics Lecture 1. Physics. In this Chapter 2, Motion, Force and Laws of Motion. If you like this video, please like, share and subscribe to our channel. Please share your valuable comments in the comment section. Okay, let us go to the today's session. First one. Now I'll discuss what is meant by rest and what is meant by motion. An object is said to be at rest if it does not change its position with respect to its surroundings with the passage of time. So, when the object is said to be at rest, when the position of the body with respect to its surroundings does not change with the time, then it is said to be at rest. Next, motion. When the position of the body with respect to its surroundings changes with the time, then it is said to be in motion. Next, we will discuss distance. The actual length of the path travelled by a body in a unit time is known as distance. Or distance nothing but total length of the path, or the distance travelled by a body is the actual length of the path covered by a moving body irrespective of the direction in which the body moves is known as distance. Rest, motion, distance. Rest nothing but does not change its position with respect to time. Motion nothing but changes with respect to time its position. So when the body is said to be in motion, its position changes with respect to time and surroundings. So here we will discuss rest, motion discussed. Next, distance. The actual length of the path travelled by a body in a unit time is known as distance, or distance nothing but total length of the path, or distance travelled by a body, the actual length of the path covered by a moving body irrespective of the direction in which the body moves is known as the distance. Okay. Next, when a body moves from one position to another, the shortest or straight line distance between the initial and final position is known as the displacement. Here, this is about the displacement. Displacement nothing but the shortest distance between initial and final position is known as displacement. SI unit of displacement is meter. It is denoted by letter M. Displacement is a vector quantity. So, displacement nothing but the shortest distance between initial point and final point is known as displacement. So, SI unit of displacement is meter. Displacement is a vector quantity. Next, uniform motion. Uniform motion nothing but when a body covers equal distances in equal intervals of time. However, small intervals may be, then the body is said to be in uniform motion. So, a body has a uniform motion if it travels equal distances in equal intervals of time. Next, non-uniform motion. A body has a non-uniform motion if it travels unequal distances in equal intervals of time. So, when a body covers unequal distances in equal intervals of time, however, small intervals may be, then the body is said to be in non-uniform motion. Next, what is meant by speed? Rate of distance is known as speed, or distance travelled by a moving body in a unit time is called speed. SI unit of speed is meters per second. Speed is equals to distance travelled by time taken. So, speed is a scalar quantity. What is speed? Distance travelled by a moving body in a unit time is called speed, or rate of distance is also called as speed. SI unit of speed is meters per second. Mathematically, speed can be written as distance travelled by time taken. So, average speed, the total distance travelled by total time taken. So, average distance covered by a body per unit time when the body is moving with non-uniform speed is known as average speed. So, average speed nothing but ratio of total distance travelled to the total time taken, or it can be written as average speed is equals to total distance travelled by total time taken. Average speed is also a scalar quantity. So, speed, average speed. Next, velocity. Velocity nothing but rate of displacement is known as velocity, or rate of change of motion in a specified direction is also known as velocity. So, velocity of a body is defined as the displacement produced per unit time. It is the distance travelled by a body per unit time in a given direction is known as velocity. SI unit of velocity is meters per second. Velocity is equals to displacement by time. So that's why we can define shortly velocity is rate of displacement. So velocity is equals to displacement by time taken. Next we will discuss average velocity. It is defined as the total displacement covered divided by the total time taken. So average velocity nothing but it is the ratio of total displacement and total time taken. So velocity nothing but rate of displacement is known as velocity, or rate of change of motion in a specified direction is also known as velocity. SI unit of velocity is meters per second. So velocity is equals to displacement by time taken. Average velocity nothing but it is defined as the ratio of total displacement to the total time taken. Velocity is a vector quantity. Why? Because it mentions the both magnitude and direction. Next, acceleration. Acceleration nothing but rate of change in velocity is known as acceleration, or it is defined as the rate of change of velocity with the time. So nothing but acceleration is equals to change in velocity by time taken. Here we can write the acceleration. This is denoted by letter A. A is equals to change in velocity nothing but v minus u time taken t. So acceleration is equals to change in velocity by time taken. From this, taking cross multiplication, v minus u is equals to at. So from this, v is equals to u plus at. This is the first equation of motion. Here, what is acceleration? Rate of change in velocity is known as acceleration, or it is defined as the rate of change of velocity with the time. Acceleration is equals to change in velocity by time taken. So, A acceleration nothing but A is equals to v minus u by t. By cross multiplication, v minus u is equals to at. So v is equals to u plus at. SI unit of acceleration is meters per second square. Next, retardation. Retardation nothing but negative acceleration is called retardation, or another name deceleration. Either retardation or deceleration same. So retardation nothing but negative acceleration is called retardation. Next we will discuss uniform acceleration. When a body covers equal displacements or equal change in velocities in equal intervals of time, then it is said to be uniform acceleration. So here a body has uniform acceleration if it travels in a straight line and its velocity increases by equal amounts in equal intervals of time For example, motion of a freely falling body. So here uniform acceleration nothing but equal change in velocities in equal intervals of time. So when a body covers equal change in velocities in equal intervals of time, then it is said to be in uniform acceleration. Example, motion of a freely falling body. Okay. Next. Non-uniform acceleration. Non-uniform acceleration nothing but when a body covers unequal change in velocities in equal intervals of time, however small intervals may be, then the body is said to be moving with non-uniform acceleration. So here a body has a non-uniform acceleration if the velocity increases by unequal amounts in equal intervals of time. In other words, a body has a non-uniform acceleration if its velocity changes at a non-uniform rate. Okay, non-uniform nothing but unequal change in velocities in equal intervals of time. Okay, next. Uniform circular motion. Motion of a body along a circular path with uniform speed is called uniform circular motion. Next, angular displacement. Angle traced at the center of the circular path during its circular motion is called angular displacement. It is denoted by theta. It is measured in degree or radian. Next, angular velocity, that is omega, that is equals to delta theta by delta t, radians by second. Next, angular acceleration, that is alpha is equals to delta omega by delta t, radians by second square. This is about the angular displacement, angular velocity and angular acceleration. Okay, next. Centripetal acceleration. A body moving along a circular path acted upon by an acceleration directed towards the center along the radius is called the centripetal acceleration. Centripetal acceleration, that is equals to v square by r, that is equals to omega r square. So here v is equals to omega r. So and the centripetal force mv square by r is equals to m omega square r towards the center. Next, equations of motion. Now, let us discuss. These are the equations which give relation between velocity, acceleration, distance covered, time taken for a body in uniform acceleration. First one is v is equals to u plus at, where u is the initial velocity and v is the final velocity, a is the acceleration, t is time taken. Now the second equation of motion is s is equals to ut plus half a t square. S nothing but distance travelled. V square minus u square is equals to 2as. This is the third equation of motion. So first one is v is equals to u plus at, and second one is s is equals to ut plus half at square. The third equation of motion is v square minus u square is equals to 2as. Next, the fourth equation nothing but displacement of a body in the nth second is Sn is equals to u plus a by 2 into n minus half, or Sn is equals to u plus a by 2 into 2n minus 1. All equations of motion are valid for particle projected vertically upwards taking a is equals to minus g. Then time of flight is equals to time of flight nothing but total time, that is addition of or sum of time of ascent plus time of descent. Time of ascent is equals to u by g and time of descent is also equal to u by g. So total time is equal to 2u by g, that is time of flight. So time of flight is equals to 2u by g and maximum height h is equals to u square by 2z. where g is acceleration due to gravity. Okay. Thanks for watching this video.